Hi and good morning. My name is KJ Tan.
The broadcast is now starting. All attendees are in listen-only mode.
Hi and good morning. My name is KJ Tan, and today I will be the instructor for this webinar. The topic of this webinar is Quick Start Surfacing for Beginners. So in this webinar, the topic cover will be only three main things, which are why, what, why, and also how. Okay, so just three simple things: what, why, and how. So before we continue further, let us ask ourselves, what is surface? So why we need to use surface? And lastly, how do we create this surface? So all of this will be covered in this session, and there will be one example or we call case study at the end of the session to show the use of surface. So now in SolidWorks, we only have two types, which are solid, body, and also surface. So what is a solid and what is a surface? Let me use a very simple example, which is a cube. Okay, so here you can see there's two cubes. One is made up of solid and also one is made up of surface. At one glance, you see that there's no significant difference between both of them. So now you see a cube has 6 faces. So each of these faces represent a surface, and the combination of these 6 faces makes a fully confined volume which can be formed as a solid. As for surface, it is only a face with infinitesimal thickness and it also can form a cube by creating 6 faces combining together. So let us look in detail what is a solid and what is a surface. So first one is solid. So solid, okay, so we use like the same example, which is the cube. So let us draw the cube now, okay, in SolidWorks. Okay, so let me go into SolidWorks. Okay. So here, let's draw a cube. Okay, by simple extrude. Okay, for example, I sketch on the top plane. Yeah, I use a simple cube. Okay, 50 and also 50 here. Okay, so and then I use extrude, make it a 50 also. Okay, now we have a solid body cubes. So at here we have a cube. Okay, looking back at the slide. Okay, so a cube, okay, has 6 faces. Okay, so 6 faces, and each edge in each edge there's 2 surface. It is connected to only 2 surface. Okay, this is the definition of solid. So for each edge, it is connected to only 2 surface. It cannot be connected to more than 2 surface. Okay, so all of the face are bounded by a continuous loops of edges. Okay, so as you can see here, all of them are continuously bounded. There's no like somewhat extrude up or anything. Okay, so next is no self-intersection. So the face cannot touch each other or pass through each other faces. Okay, so the face, the solid, okay, the face here cannot be one face is like 60 mm and another face is like 20 mm. Okay, so this one cannot be done. Okay, but this one can be done in surface, will be shown later. Okay, so next, okay, is an enclosed volume. So the whole cube is enclosed. Okay, meaning there's no open area and no opening between each of them. Okay, so as you can see, all of the lines are connected. Okay, so it has an enclosed volume. So now we have an enclosed volume. Okay, so meaning it has also mesh property. Okay, for example, I assign the material. Yeah, for example, I assign some simple material, yeah, like aluminum alloy. Close it. Okay, so I go to evaluate. I go to mesh property. We can see that it has mass, it has volume, and all the other specification. Yeah, this is very important. So in in solid body, we have mesh properties. Okay, so let us look at surface. Okay, the cube made using surface. Okay, so same thing. Let us hide this one. Okay, so same thing. We sketch at the top plane. Okay, now I make another circle, another cube. Okay, so same thing is 50 and also 50 here. Okay, so to make it easier, we make a comparison between two of them later. Okay, so here we have the cube, so we are extruding, same also 50. Sorry. So we have here. Okay, so now we use surface extrude. Okay, this one I will discuss it later. Okay, so you can see the extrude form a surface with no thick, very small thickness. We can say no thickness. Okay, so to make a cube, I will use other features. Okay, so we'll cover this later. Okay, so let us continue make this cube first. Okay, so the cube is done. Okay, so let us go back to the slide. Okay, so next is surface. So what applies to solid body, okay, does not necessarily hold true for surface. For example, the intersection. Okay, so surface can intersect each other. Okay, we will see that later. Okay, the next one. So for surface, that's not necessary to form an enclosed volume. Okay, so I can move the face out of the cube. Okay, let's see an example. Okay, for example here, okay, this one. Okay, I can move the face. Okay, remove this face out of it. So maybe I move it like this. Okay, okay. Okay, what type of face? Okay, 20. Okay, there's some technical error here. Okay, you can see that. Okay, the face is moved, so there's no enclosed volume inside each. Okay, so same also for here. Okay, if we move this face, okay, same also, the whole cube is open. Okay, you can see the whole cube is open. Okay, so it does not necessarily need to have an enclosed volume. Okay, so let us see the intersection. Okay, so let me hide this. Let's see an intersection between each of them. Okay, so let me hide this also. Go back in. Okay, so now we have this hole. Okay, we have this hole. So I want to make a surface inside of this cube. Okay, so let me see. Let me create a offset plane. Okay, make it 20 mm. Okay, flip it. So the plane is inside. Okay, so now I want to draw it inside. Okay, for example, I draw a inside. Okay, so same thing. Use surface, use planar plane. Okay, so you can see that the surface can overlap each other. Okay, so there's no problem. But in solid, it cannot overlap each other like this. Okay, so so in surface we can do some other things. Okay, so here, okay, next. So meaning if there's no enclosed volume, okay, so the meaning no volume equals to no mesh. So here we can see that if we go to evaluate, okay, so I need to suppress this first. Okay, so there's no mesh property. We cannot see any mesh property. Okay, so we cannot see any mesh property. Okay, so meaning you, no matter how many surface you add, you cannot increase the weight, or it has no impact on the component's weight. Okay, so let us compare in detail surface and also solid also. Okay, so I just press this, so I show it. Okay, let's compare both of them. Okay, now we have these two. Okay, so what if I do a section view? Okay, I want to do a section view. Okay, let me suppress this first. Okay, this one. Okay, so here the same two cube. Okay, so what if I do a section view? Okay, okay, you can see clearly that there's a hollow cavity inside the surface, while in solid it is full. Okay, so when we want to see which one is a solid, which one is surface, we can do something like this. Okay, but the most important difference is the mesh property. Okay, by using a surface, there's no mesh, no volume. You cannot calculate anything at all. Okay, you cannot calculate all the mesh property. Okay, as for solid, again, I suppress all of this. Okay, so for solid, we still have mesh property. You can find all the mesh property. Okay, so here we have done what is a solid, and also what is a surface. Okay, so so next we move on to we see there's a lot of difference between solid and surface also, correct? So what is common between what is a common thing between a solid and also a surface? Okay, so let us see. Okay, so the similarities for a solid and a surface is that both of them need input geometry, meaning they need a sketch, they need an input sketch. Without an input sketch, they cannot be formed. Okay, so we need to draw a sketch first. Okay, draw a sketch first here. Okay, we need to draw a sketch first. Then we only can extrude it become a solid also, or a surface. Okay, next. So solid and surface, they can mix and match. They can mix together. So meaning a surface can be converted into a solid body, or a solid body can be converted into a surface body. Okay, let us see an example here. Okay, so let us unsuppress this. Okay, okay, so close this. Okay, okay, here this is a solid body, correct? So this is a surface body, correct? So we can convert into a solid body. Okay, so just by using here, we will learn this in later chapter. Okay, I can click on this, the whole thing. Okay, I just select from here, surface, surface as well. Okay, here we can see that we can try to form a solid. Okay, so we have formed the solid. Let us see the cross-sectional view. So both of them, okay, both of them become a solid. You see, this surface has become a solid. Okay, so same also for solid body to become a surface. Okay, so I can just set do this. So I click. So now I suppress this. Okay, now I hide this. Yeah, now we do a section. What section? So the solid also become a surface. Okay, so meaning they can mix and match with each other. So they can. Okay, let us go back to the slide. Okay, so surface can be converted into a solid body, and solid body can be converted into a surface body. Okay, so they can use each other. Okay, so there won't be any error when you combine both of them. Okay, so now that we know what is a solid, what is solid body, what is a surface body, so we ask the second question: why we need to use surface? Why can't I just use solid? Because in the real world, everything is solid. There's no like surface which is that has no thickness. Okay, so next we ask why. Okay, so before that, we need to know how to identify each of the, which one is solid, which one is surface. Okay, as I mentioned just now, we use section view, okay, to see. Okay, second one is each of them has their own type of folder here. Okay, each of them has their own type of folder. Here for solid body, they have solid body folder. For surface body, they have their own surface body folder. Okay, by just clicking on this, okay, we know which one is which one. Okay, you highlight which one is which one. For example, here. Okay, for example, here and here. Here we just click on this, you highlight which one is which one, so we can differentiate easily. Okay, continue on. Okay, so next we ask the question why we want to use surface. Okay, so surface, okay, sometimes the first thing that we use surface is because some of the geometry are too complex to create using solid features. Okay, for example, this Scooby-Doo model here, okay, this dog, okay, if we use solid body, it is impossible to create this. Okay, so another example is this mouse. Okay, so you see this mouse has a curvature. Okay, in solid bodies, it is very hard to create a irregular curvature surface, irregular curvature solid. I mean, okay, so we need to have something to manipulate the curvature so that we can create this mouse. Okay, so that we can create this mouse. So however, in surface, we can manipulate the curvature easily and get the shape we want. So this move on to our second point: easier to control the curvature with surfaces. Okay, so we can change how curved is a surface. Okay, we will do this later. So we can change. We want how curved is this surface, how irregular is this surface. Okay, we can change all of this. Okay, so this makes us easier to create a complex model. Okay, because you know that by creating a surface, make it an enclosed volume, we can make it a solid body. So when we want to model something, we can do something like this. Okay, other than that, surface can be used as a reference geometry to create a solid features, which I mentioned just now. We make a confined volume, okay, using a surface, and then we can create a solid features. Okay. Next, surface can be also used to repair imported geometry. For example, parasolid file. Okay, maybe there's some when we transfer into SolidWorks, there's some miss or error inside it, so we can use surface to repair it. Okay, so lastly, surface can often use edges instead of a closed profile. So by using an edge, we can straight away create a surface. Okay, so this reduce a lot of workload. Okay, so there's a lot of different uses of surface. Okay, we will see our example at the end of this webinar, whereby we want to make a cut into a curvature, a curved cylinder. Yeah, we will do this later. Okay, so now what we know that why we want to use surface. Again, the next one is how do we create surface. Okay, so here there's a lot of we call surface command or surface features. Okay, so first, where to find this? Okay, very easy. There's 4 methods. Okay, so first method is go to the menu, insert, surface, then all here. Okay, so I show here. So insert, surface, all of the surface tools are here. Okay, the second method is through command manager here. Okay, we just click on the surface tab, all of the tools are here. Okay, so next one is through the tools bar. Okay, here we can show tools bar. Okay, we can customize it. We can show surface toolbar. Where is surface toolbar? Yeah. Surface. Okay, click. Okay, so all the surface toolbar are here. Okay, so if you don't want it, you can just customize over here. The surface toolbar is gone. Okay, last one is the shortcut key. Yeah, for now I didn't customize my shortcut key, so all of that are here. We can customize it here. Okay, so there's 4 methods of finding all the surface tool. Okay, so we'll discuss each of these surface tool one by one later. Okay, so next, the first one, we use extruded surface. So basically, extruded surface is same as extrude boss or base in solid. Okay, so let us see an example here. Okay, so same thing, same like when we want to do a solid body. We need to select a plane first, sketch it. Okay, then after that we only draw the sketch. Give it 50 mm. Yeah, like just now example 50 mm. Okay, so next we use features, extrude boss or base. Okay, then we can start to pull it around, something like this. Correct? So same thing for surface. Okay, click on surface tab, extruded surface. Okay, so it's the same thing, just that the end result is a surface. Okay, so we can create a surface using extruded surface. This is the most common and easiest method to extrude the surface. Okay, to create a surface. Okay, second one. Okay, let's go to the second one. Is revolve surface. Okay, so again, it is exactly the same as solid revolve, except it creates a surface. Yeah, let us see. Okay, here let us go to a new one. New example. Here, same thing. We need to select a sketch. Okay, so same thing for revolve. The first, there's 2 things we need. One is axis. Okay, so we will use a center line to create an axis. Second one is the profile to revolve. Okay, for a surface, we can straight away use one line. Okay, we can straight away use one line. Okay, same thing here. So surface, revolve surface. Okay, it will automatically select here. So everything is the same as revolve boss or base, just that now we use in surface. Okay, now the end product is a surface. Okay, the end product is a surface. So basically these two are the same. Okay, as solid. Okay, so let's continue on. Okay, next is plane surface. Okay, what I mean by planar surface, meaning we create a surface using the sketch. We create a planar surface within a 2D sketch. Okay, we can use 2 or more edges to create it. Okay, so let us see an example here. So for example, this cylinder, okay, we want to create a plane surface. Okay, so meaning it is in plane with these edges. Okay, so it has the same plane as these edges. Okay, so the planar surface is here. Okay, we just click and then we click OK. So we have created a planar surface. It's just easily create, click. Okay, so sometimes, okay, for example here, okay, we need to select two edges to define, because when one edges, you don't know where should the plane go. So we need to select another edges to determine where the plane need to go. Okay, so this is planar surface. Okay, so next we use swipe surface. So same again, it is same as solid swipe, except it create a surface. Okay, so same for swipe, we need two things. Okay, two things only: a profile and also the path. Okay, so let's do an example here. Okay, so I go to the front plane. First I sketch the path first. Okay, I want a curvy path, so just I use spline to draw a path. Okay, next I create a profile. Okay, so I can do a reference plane here. Okay, so set to this surface. Okay. So the profile and the profile and the sketch must be 90 degrees to each other. Okay, for example, when you draw on front plane, you need to draw on the right plane. Okay, for example, something like this. Okay, so you can see that this profile and this profile, their plane is 90 degrees towards each other. Okay, using that only you can do a swipe. Okay, same thing, surface swipe. So you see it's very familiar. It's same as the solid swipe. We use surface, profile, and so path. Okay, just click on it. Okay, so the swipe surface is done. Yeah, so we have done this swipe surface. So next we'll go to loft. Same. Okay, so it is same as solid extrude loft. So same thing except it create a surface. So here we can control how can we manipulate the surface. Okay, so let us see how to create it. Okay, so here I have draw a sketch. Okay, so it doesn't matter how you create a sketch. So as long as it's logic. Okay, so meaning when this sketch connect to this sketch, so it can create a surface. So sometimes if for example, you are sketching here and here, and it cannot be connected because it's not logical. So when you want to create a surface, you need to think of the logic. Can this surface be created? Okay, can this sketch create this surface? Okay, so let us use a loft. Okay, click on this. Click on this. Okay, so the surface is created. Okay, so I can also click on this. So you can see that you will find the shortest path. Okay, between this sketch, the first sketch and the second sketch and the third sketch. Okay, so you will find the shortest path between three of the sketch. Okay, next. Okay, so we have done this. Okay, other than we can close the loft, for example, and click on it. So you form a closed one. So meaning the third profile will connect it back to the first profile. Okay, so then we can create a loft surface. Okay, this is our loft surface. Okay, so loft surface, it connects the sketch using the shortest possible route. Okay, So next is boundary surface. Okay, so it is same as solid solid boundary. So same thing is except it created surface. So the technique is about the same like loft. Okay, but it is very powerful and we can control the tangency of the surface. Okay, so excuse me. So let us go and see how this boundary surface can be created. Okay, here. So now I don't want this surface lock first. Okay, delete this. Okay, I go back to this sketch. So I use boundary surface. Click on this sketch. Click on this sketch. So same thing. It has the same technique as the loft. Okay, but except now we can control the curvature. For example, I go here. Okay, so I can control the curvature. Okay, I will show later on. Okay, so here you can see that there's a lot of spikes here. Yeah, there's a lot of purple color spike and green color spike. Okay, this spike shows how curved is the surface. Meaning, if the spike is very short, meaning the surface is not really curved. If the spike is very long, meaning here is very curved. So by having this spike, you have a general preview on how the surface will look like. Yeah, it will help you when you are designing something. Okay, so next we can change the curvature of this profile. For example, I want normal to profile. Okay, so I can just pull normal to this profile. Okay, so here I also can change to normal to profile. I can also pull. Okay, so this is a very powerful tool. Okay, so we can manipulate the curvature of this sketch, so it can come out a totally different surface as loft. Okay, so here we can manipulate and create the surface we want. So we can, through this manipulation, we can create a complex surface. Okay, so for now I will use back the loft first. Okay, for the later example. Okay, so next we continue. Offset surface. Okay, so offset surface, okay, meaning it is usually to create a copy of the surface. Okay, so it is usually used to create a surface. Okay, so you can create a surface with a 0 mm offset. Okay, I will show you later. Okay, so it can offset inwards, outwards. Okay, it can be also used on the solid bodies. So I'll show here. Okay, so let me find the okay, I found here. Okay, here. Okay, so this is okay, if you don't know which one is which one, so we can click on this. This is a surface body, this is a solid body. Okay, so for example, I want to offset this surface, this face. Yeah. So basically it just create another planar surface from this face. Okay, so what if I use it to a solid body? Same thing also. Okay, I need to click on. Okay, so now I determine the. Okay, so if I hide this. Okay, so hide this. Okay, so we can see that a surface body is created here. Okay, so a surface body is created by using a solid body. Okay, so this is like a planar space, correct? So let us see a curved surface, circular surface like a cylinder. So same thing. Okay, so we can offset the surface, 10 mm. Okay, it's offset inwards. Okay, so I can change the direction, inwards, outwards, inwards, outwards. So let me hide this for you to see clearer. Okay, so here I can offset inwards, outwards. So no matter what face, as long as it's a face, we can offset. So it will help us in making, for example, like assembly. When we want to make something, we can use a surface, offset surface to make it for us. Okay, it will help us. Okay, so next you go to fill surface. Okay, so fill surface, it is useful for closing open surface. For example, when you want to make a solid body, okay, we must close the volume, correct? So we can use this fill surface to help us to close this. Okay, so it can do on a simple or sometimes complex geometry. However, if the geometry is too complex, it cannot calculate out how the surface can be filled. So we need to be careful when we use this fill surface. Okay, so for example, I use this cylinder. Yeah, I use this cylinder. So I can just use fill surface. Okay, fill it. Fill this. Okay, okay. So the cylinder is filled. Okay, so let me show one more time. Okay, so there's inside cannot be closed, right? So I can just fill surface. So it will make an enclosed volume. Okay, what if I have a bit complex surface like this? Okay, same also, you can use fill surface. Okay, on this. Okay, here there's few types of how the surface can be made. If contact, is just make a planar surface, okay, between the edge. Okay, so if I use a tangent, okay, so you make a tangent surface. Okay, last one, curvature. Okay, same thing. Okay, here we can control the curvature. Okay, so by using this fill surface, okay, we can create a solid body easy. Okay, form a solid. So it becomes a solid body. Okay, so this is the powerful of fill surface. Next, okay, is fillets. Okay, so fillets is same like what we do fillets in what we use fillets in solid body. Okay, it's the same thing. So let me sketch a normal sketch. Okay, put the surface. Okay, so now I want to make a fillets. Okay, so I just click on this. Okay, just change the dimension. Okay, so I've done the fillet. Okay, however, one thing to notice is that, okay, so it will not work on separate surface body. They need to be joined together to form a one surface body. Okay, so as you can see here, it is a one surface body. It is not a two surface body. Okay, so let us see an example of one surface body. Okay, let me roll back. Yeah, left this. Okay, let me sketch two surface body. Same thing, give it a 50. Yeah, actually 50. Okay, 55. Okay, sketch second time. Okay, 50. Okay, actually 65. So if we create the surface one time by one time, you form two surface body. Okay, so you see when now we have two surface body when we try to use fillet. Okay, so I want to click on here. So I cannot click on here because it is a two surface body. So I need to knit them up, become one surface body, and then I can fillet it. Okay, so this is fillets. Next, we'll go to extend surface. Okay, it is used to extend the surface edge. For example, you need to pull it a bit or make it bigger a bit. Okay, so it can follow the existing geometry of surface or extend in linear fashion. So let's see an example that we have done. Okay, for example, this surface. Okay, so now we want to extend surface. Extend surface is here. So just click on it. So I need to select the edges. For example, here. Here I can just pull. Here we can change. Is it same surface or you want linear? The same surface meaning you follow this surface curvature. Linear meaning you go straight only. Okay, so this is the two things that we can do using extend surface. Okay, we can extend this surface also. This is here. Here you follow the curvature. Okay, by using this we can create a complex surface. Okay, so next, trim surface. Okay, trim surface, it is used to cut out a surface. Okay, back to a boundary defined by another surface, or it can be defined another surface, or we can use a sketch to trim it. Okay, so let us see an example. For example, the cylinder. Let's find the cylinder here. Okay, so let me suppress this. Okay, so let me draw a surface plane. Okay, I create top plane. Okay, so now I sketch on this plane. Make a plane surface. Okay, here. So here, okay, so trim, we can use a surface to trim it. For example, like this. Okay, so I can trim it. Okay, what is the trim tool I want? Okay, for example, this is the trim tool I want. Okay, so this one is the thing I want. Okay, so I want to keep the selection or remove the selection. So let us see the difference. I remove the selection, meaning the one that I select in the second part will be removed. Okay, so if I keep the selection, the one I select in the second part will be kept. Okay, the others will be removed. Okay, so we can also use a sketch to trim. Okay, for example, front plane, sketch something like this, another rectangle. Okay, let me sketch another rectangle. Okay, so here, okay, this sketch. Okay, same thing, go to surface, trim surface. Okay, I use this sketch to trim, so I will use one. Okay, so you trim out the thing. Okay, so or for example here, I can trim here. The sketch is the trim tool, so my surface body, I want to use all the surface. Okay, so I can just click on this. Okay, this, okay, and also this. Okay, I just click OK. Okay, so I will keep the selection. So we can use two things to trim the surface. One is using sketch. One is using surface. Okay, we can select different boundary. Yeah, next. So knit surface. Okay, so knit surface is we just join multiple surface. Okay, so I've shown just now. Okay, so let me use another example. Okay, use this example again. So just now you have something like this. So in this folder it shows two surface body. So when we knit the surface, we click this surface and click this surface. We click merge entity. Okay, you merge into one surface body. So sometimes, for example, the fillers, we need one surface body only, we can do it. Okay, so this surface also can be used to make a solid. Okay, for example, this one that we done. Okay, Hereby now we have 3 surfaces, correct? 1, 1, 2, 3. So I use knit surface 1, 2, 3. So here we can try to form a solid. So it can form a solid. You see, a solid body is formed. Okay, so this is knit surface. Okay, so next you go to intersect. Okay, so it is a very powerful tool. Okay, we can form a solid body by using the intersection between all the surface. Okay, for example here. Okay, so let me draw something like this out. Okay, okay, here let's sketch on the front plane. Okay, use a center 50, 50. Okay, so next I'll extrude the surface. Okay, next same thing from plane. Yeah, I use a circle. Yeah, I want out a bit. Okay, something like this. Same thing. I'll extrude. Okay. So now I have these two surfaces. So I can use intersect. Okay. So I can use the intersection. Okay. Intersect to find the intersection between these two surfaces and form a solid body. Okay. For example, we can go find here in the set. Okay. Is in here. Okay, in features intersect. Okay, click on this. Okay, I click on this surface and also this surface. Okay, we find the intersection. Okay. Oh, we need to make a closed volume first. Sorry, yeah. Okay, let me make a closed volume first. Okay, for example, here we can make a planar surface. Okay. Here also we can make a planar surface. Click on it. Okay. So we have a closed volume. Okay, so now we go to the intersect. Okay. Here this whole thing. And also this thing. Find the intersection. Okay, we have C region 1 and region 2. So for example, I want this region 1, I click on it. Okay, I click OK. So now if I hide this, all this, yeah, I hide this. Okay, for example, I hide the surface body, hiding. Then we can see that, okay, the solid body is formed. The solid body is formed by using intersect. Okay, so next is thicken. Thicken, we can use thicken to make a solid body also. So there's actually 3 methods to make a solid body by using knit. Okay, second one is intersect, and last one is this one, thicken. Okay, let me use an example here. Okay, so here, let's go back to here. Okay, so I can click on thicken. Okay, so it let you select how you want to thicken it. Is it a mid plane thicken? Is it up or bottom? Okay, for example, I want this surface. Yeah, mid plane, give it 20. Okay, it will become a solid body. Okay, so as a conclusion, there's a 3 methods to use to make a solid body from surface. Okay, so next is some of the surface command tool to help you make a surface. For example, split line. Okay, so let me draw one. Okay, here we sketch on this. Okay, we exclude this. Okay, let me change the sketch first. Okay, okay, exclude this. Okay, so sketch on right plane. Okay, make a circle. Okay, we can use a split line. Okay, to make here towards here or towards here. Okay, we can select which face we want this sketch to go into. For example, I select these two faces, right? So you see that the sketch will move into these two surfaces. So it will become two different faces. However, it is still a same one solid body, one surface body. However, we can select two faces. Okay, for example, I want to make a hole. I can select this hole, delete. Okay, no. Okay, I can here delete surface. Okay, delete face. I can delete, make a hole. Okay, so split line can help us make a different surface when we want to do something like we don't want to have this surface, or we want to make some changes on this surface only. So split line can help us a lot. Okay, so next is delete hole. So for example, I have this hole. Okay, usually in solid body, when you click on it, we just want to click delete. Okay, it only ask you to delete the features. However, in surface, it will ask you whether you want to delete the hole only or you want to delete the features. For example, if I delete the hole will be deleted. Okay, for example, if I delete the features, okay, so I will delete the whole features. Okay, so this is the delete whole command. Okay, so lastly, we will do a case study. So we want to make a cut on this curved cylinder. You see, this cylinder has 1 curve, 2 curve, 3 curve, 4 curve. So you have 4 circular surface, and if you use extrude cut, it's not it's not possible to be formed. Okay, so let us see this case study. Okay, so we want to make something like this. Okay, so let me roll back. Okay, so here. Okay, so let me convert entity. Okay. Okay, for example, I want to make this cut into this solid body. So if I use the extrude cut, so there's no features for us to cut this. Okay, up to surface you cannot cut, up to surface also, offset from surface also. All of this we cannot use to cut it. Okay, so there's a problem in cutting this. So we need to use surface tool to help us to make a cut into this. Okay, for example, first one I use offset surface first. Okay, just click on it, click on all this surface. Okay, I have all this surface now. Okay, so I make a 0 mm offset. Okay, so now I have this offset surface. Okay, let me hide this first. Okay, so I have this offset surface. Now I want to make a cut here, so I can trim this surface first. Okay, so I trim this surface first. Okay, not this plane. Okay, so as I mentioned just last time, earlier, we can trim using sketch. Okay, so I can just trim up this. Okay, maybe I want to trim up to here. Okay, we can trim the surface using sketches. So let me see trim. Okay, so this one is to remove. Okay, so we have left this surface only. Now let us unhide this. Okay, so now we can use extrude cut. Okay, so same this. Okay, now we can use the surface, up to surface. We can click on this surface. We can use offset from surface. We can click on this surface. Okay, so we can offset like, because we want to cut the 2 mm. Okay, cut into it. So let us see, is it 2 mm? Okay, so okay. Okay, we need to cut it inside. Okay, okay. Okay, so now we hide this surface. Okay, so we have managed to make a cut into this surface. So this is one of the example of how we use surface to help us to do something is not possible using solid features. Okay, so let us continue on the slide. Okay, so we have to do a case study on making a cut on this cylinder. Okay, so next I think that's all from here. So I think we have reached the end of this session. So thank you very much. So if there are any questions, don't hesitate to contact me. Okay, so I will help you in your, maybe you have faced some problem when you want to do a surface. Okay, you can contact me through this email or my phone number. Okay, thank you very much and see you next time.